So here is a momentum problem with multiple objects, and we're going to treat it much like we've treated the other ones in that we're going to make an MVP chart in order to solve it. So we have our before and after. The difference in this one is we're going to have multiple objects. In this case we've got a car and we've got a truck. So there's a car before and there is a truck before, and then afterwards there is a car and a truck. And each of these is going to get its own set of MVP values: mass, velocity, and momentum. So we'll just draw those all in, and we'll figure out, we're going to start reading the problem and figuring out what we know. So the car's mass is 800 kilograms. So we're going to write that in for the car, and it's basically going to be the same mass after. The truck's mass is 1800 kilograms. And that's pretty much going to be the same after as well. So the problem says that the car is moving to the right at a speed of 50 meters per second. And it hits a stationary truck, so the truck is not moving. Then after they crash, the car continues moving forward at 12 meters per second. How fast does the truck move forward at? So this is a lot like these other momentum problems that we did. The big difference here is we're assuming there are no outside forces. It doesn't say anything about outside forces, so we make that assumption. And if there are no outside forces, delta P is 0, meaning the momentum before and after is the same. And this is known as the law of conservation of momentum. As long as there are no outside forces, the momentum before and after an event they're equal. And so that's how we're going to solve this problem. So the momentum of the car before the crash is 800 times 50, or 40,000 kilogram meters per second. The momentum of the truck before the crash was 0 because it wasn't moving. So that means the total momentum before the crash is all in the car, it's 40,000. And since there's no outside forces, that means the total momentum after the crash will also be 40,000 kilogram meters per second. So the car's momentum after is 800 times 12, or 9,600 kilogram meters per second. And the total momentum was 40,000. So how much momentum does the truck need to make that work? Well, we'll take the difference between 40,000 and 9,600. The truck must have 30,400 kilogram meters per second. So the truck gained most of the momentum from the car. So we can fill that in. And now it's just a matter of finding its velocity. So we say 30,400 equals 1,800 times v. And we can divide those and find the velocity of the truck. So after getting hit by the car, the truck will be going about 16.9 meters per second. And that is basically how we go about doing this. So the car was going 50, and it transferred a lot of momentum to the truck, but the truck is more massive, so the truck's not going to be going nearly as fast as the car was. Plus, the car still retained some of its momentum. And that's how you do it. So let's do one more just to get the idea. So we will, again, divide up before and after. And we're going to count the objects. In this case, we have two bumper cars. We've got a yellow bumper car and a black bumper car. So I'm just going to write yellow and black on each side. Yellow and black. And again, I'm going to put columns for mass, velocity, momentum, mass, velocity, momentum for each object involved. And we're going to fill in what we know. So the yellow bumper car is 400 kilograms for each side. The black bumper car is 350. Okay. Now, the yellow bumper car is moving right at 4 meters per second. So I'm going to write 4 meters per second for yellow. The black is moving 5 to the left. Since it's moving in the opposite direction, we're going to say it's negative 5 meters per second, not just 5. That will be important later. After they collide, the yellow car goes left at 4.3. So that means the yellow car is going to be negative 4.3 after the crash. And we don't know what the black bumper car is going to do at the moment. So it's just a matter of solving for all the momentums that we know. So the momentum of the yellow car before, 400 times 4, is 1,600 kilogram meters per second. The momentum of the black car before, 350 times negative 5, is negative 1,750 kilogram meters per second. And the momentum of the yellow, 400 times negative 4.3, is negative 720, negative 1720, rather, kilogram meters per second. So then we want to find out what the momentum of the black car is after. Remember, the change in momentum is 0 because there are no outside forces. So the total momentum of the yellow and black car before is 1600 plus negative 1750, or negative 150 kilogram meters per second before the crash, which means it also must be negative 150 after the crash. And since this is negative 1720, we need some number that when you add it to negative 1720, you get negative 150. It's going to have to be a positive number, but it's going to have to be less than 1720. 1720 will get it to 0. We want it to be still negative. So it's just a matter of taking the difference, 1720 minus 150. So 1720 minus 150, and I get 1570. And if we want to confirm that, you can say 1570 plus negative 1720 does give you negative 150, but whatever. So now we're going to find the velocity. So again, 1570 equals 350 times v. So just solve for v, and it's a positive number. It's just about 4.5. I'm going to round it, meters per second. And that's how fast the black car bounces. It's going to be going to the right because it's positive. But bottom line, the momentum was conserved. And we just did this by setting up this chart. So this chart can solve a lot of momentum problems if you're just taking your time, keeping track of your numbers, and making sure that whatever you have before is equal to whatever you have after. And that's it. So until next time, I am Derek Genova. Have a delightful day.